is our chemistry class for today, chemistry. We are going to start with isotopy. What is isotopy? Isotopy is a phenomenon whereby atoms of the same element, let's say atoms of the same element are X and S. X is an atom. This is a symbol representing an element. Now let's assume it is 17.7 and we have 17.35. Now these numbers below that are usually written with an element are called the atomic number, and this number up here is called the atomic mass. The same thing here. Now what you observe here is that the atomic number are the same, but the atomic masses or mass numbers are different. This is 35 and this is 37. Now this phenomenon is referred to as isotopy. Isotopy is a phenomenon or is a case study where the atomic masses differ but the atomic numbers are constant. That is, they are for the same element. And the main cause of isotopy is because of the difference in neutron numbers. You have to know this because this is an answer to a Jamb question on its own. Because of the difference in neutron numbers. That is the reason why isotopes exist. We have different isotopes. Chlorine forms isotope, that is 37 17Ca, 17Cl and 35 17Ca. Hydrogen forms isotopes, that is 11H, 21H, 31H, also called protium, deuterium and tritium. This tritium is called radioactive hydrogen because it's the only radioactive isotope of hydrogen there. So, and so on and so forth. So how do you detect isotopes without being told? There's one sure way of detecting isotopes without being told. Once you have an element whose atomic mass is not a whole number, if your atomic mass is not a whole number, then there are higher chances that that substance is an isotope of an element. An isotope of an element, that is, it exhibits isotopy. Note that. Now, of course, you should be able to know the difference between the components of an atom. Before I continue, components of an atom. First, you should know we have the proton, the neutron, and the electron. I'm coming back to this better. Now, let's try to calculate the relative abundances and also to calculate the relative atomic mass of isotopes. An atom X has 90% 63 lithium and 10% 73 lithium isotopic mixture. Full stop. Find its relative atomic mass, that is sometimes written as RAM. Now, to solve this now, what to do is very simple. Look at it. What is changing here is 6 and 7, which I've explained before as mass numbers. Those are the things that are changing. So what we do is that we take this, that is 90% of 6 plus 10% of what? 7. Good. So we have what? 90 over 100, that's percent, times 6 plus 10 over 100 times 7. Of course, that should give us what? So this should give us 5.4 plus, and this should give us 0.7. Therefore, when we add it together, we get 6.1. Therefore, the relative atomic mass is equal to 6.1, not 6.1 gram per mole. Why? Because atomic mass has no units. Relative atomic mass has no units. If the question is to find the relative molecular mass, it would have been 6.1 gram per mole. Note the difference. molecular mass, atomic mass. Molecular mass, you include gram per mole. Atomic mass, it has no unit. An element X has a relative atomic mass of 35.5 with isotopes 3517 Cl and 3717 Cl. Now the question is, find the relative abundance of each of these isotopes. It's a Jamb question, so let's solve it together. Now, call the relative abundance of 3517 Cl, call it X, and that of 3717 Cl, call it Y. Now, you know, because of percentage, X percent plus Y percent must always give us 100%, because 100% is the highest that two of them can give us. Now, I can make Y is by saying Y is 100 minus X. Is that not? I remember from my earlier talks that here we write X over 100 times 35. Remember that, plus this is Y 100 times 37 equals to 35.5. So we have 35x over 100 multiply plus 37y over 100 equals 35.5. So we have 35x over 100 plus 37. Y is what? 100 minus x over 100 is equal to 5.5. So 35x over 100 plus 37. 37 times 100 is this, minus 37x over 100 is equal to 5.5. So you take your LCM, which is 100, you have 35x plus 37 0 minus 37x equals to 5.5. So we have 3700 minus 2x over 100 is equals to 35.5. So cross, we have 3700 minus 2s equals to 35.5 times 100 when cross. So we have 3700 minus 2x is equals to 3550. We have 3700 when you collect like terms. We have 3700 minus 3550 is equals to 2x. That is, you bring minus 2x down here, become 2x, you bring this down, become minus. So you have 150 is equals to 2x, and x will be 150 over 2, which gives 25%. Therefore, 75% of 3517 Cl is present. And of course, y is equals to 100 minus x, that gives 100 minus 75, that gives you 25%. That is 25% of 3717 Cl is what we have. If you have any other questions on isotopy, any other questions on isotopy, you can send it to Nigerian Academic .blogspot.com. Thank you.